to meet you, all of you. Today I'm Maciej, I'm the CTO called Heroes. Today I would like to present you the new communication protocol, which is Reactive Socket. In my opinion, it could be a future in microservices communication. But to be honest, there is a problem because when I was applying an abstract to the conference, the authors of Reactive Socket changed the name to RSocket, so from now we'll be talking about RSocket. This is the same. So, RSocket maintainers are Netflix and Facebook's, and it was their idea to set it up. They need some kind of abstraction layer over existing TCP, HTTP protocols, and that's why they create RSocket, leveraging all existing idea in terms of communication between services, and they created the RSocket. So who we are today, probably we are working on different components of the same products in our company. We are familiar with HTTP, at least every one of us should use HTTP. We need to have a communication between our components in our application because nowadays the software is changing. We don't have a monolithic application, we have a separate services and we need to in many times communicate have some communication between them, and we need to implement, for example, an integration with external parties, so with API from Facebook, Google, etc. What is a microservice? Just to sum up, a microservice is a small component of our application. It's responsible for a specific part of our business domain. It should be loosely coupled and we should use lightweight protocols to communicate. So nowadays in our companies, when we are making a software, it is great to divide the software between components. So let's say that we have some simple architecture where we have something like user management service, order processing service, account service. We have some API gateway built on the top of the service to provide some API for our users. And it is common when on each of service there is a different team who is working over the service, who is managing the service, and they are developing the services in different languages. So one service can be developed in Java, one in PHP, one in Node.js. And sometimes it is required that we need a communication between the services. So the typical choice, which is not the smartest choice, is choosing HTTP. So for example, we need that one service needs to request for some extra data from another service, and we are using, for example, HTTP. But somehow it is not the best choice. Why? Because HTTP has drawbacks. It is a synchronous. It's a synchronous protocol, so we cannot so when we are making a request, we need to wait for a response, and this is the only way how we can communicate with HTTP. It cannot handle many parallel requests per one silk connection, so if we would like to multiply the request in parallel, we need to have set up a different connection, so we need to have different ports, so we are using resources. The inverters of HTTP wanted to fix it, providing pipelining, but pipelining doesn't work very well because it is synchronizing the request in the queue. So if you are pushing the request through the single connection using a pipelining, you still need to receive the responses in order. And the problem with HTTP that it mainly supports request-response model, so we can only make a request and wait for a response, which is in some cases not enough nowadays. So it is not enough because in our application we need some asynchronous approach. We have many cores right now. We would like to have asynchronous operation. We need a streaming API, so we would like to have an ability just, for example, to have a publish and subscribe approach when we would like to subscribe on some topic and receive the stream of events or some kind of data. And for example, we need a persistent subscription. So when there is one service and another service, and we have subscribed for a topic for some data, and we turn off our services. So when we turn it on back, we would like to start reading the data from the place when we stopped. So this is why we need persistent subscription. So instead of using HTTP, developers are choosing different methods. We can use, for example, WebSocket, we can use RabbitMQ, we can use Aaron, we can use many different existing technologies. to solve the problems of request response cycle HTTP, which only is supported by HTTP. So this is cool, but it has main problems because it requires us to apply some communication coordinator between teams when we need to say, okay, here you are in Node.js, so we are exposing the API through the WebSocket, so we need to build something on the top of the WebSocket to be able to communicate it with our API. It's really tricky and it costs a lot of development work. So this approach causes difficulties. That's why the creators and inventors of RSocket decide to do it. So because of all I have presented so far, this problem with HTTP, this problem with communication between teams, this problem as regards maintenance, all this stuff, because of Reactive Manifesto, about a couple years ago, the smart guys in the world, in IT industry, created a Reactive Manifesto, which depicts how we should build our products to have them reliable, resilient, scalable. So if you are not familiar with Reactive Manifesto, I would like to recommend it, to just read it, because it's really cool to have it knowledge. And based on Reactive Manifesto, people created reactive streams, which is another technology which is an abstraction layer. How can we communicate it using different streams and have a safe communication? And because being reactive, after reading Reactive Manifesto, is a great choice nowadays. So RSocket, the basic concept against, for example, HTTP, is the first. The major important point is that it's asynchronous communication. It has a it provides multiplexed streams over a single connection. So what does it mean? We can have a single connection between our application. So we are using just a single port. And within this connection, we can have abstracted as multiplexed different streams. So we can have, for example, subscription over different topics, and no synchronous blocks waiting for response. So the whole API is asynchronous and ready to use in asynchronous world. What is more, it provides 4 interaction models. So HTTP provides request response. Using WebSocket, we can have a streaming, but RSocket provides 4 of them built in the protocol. It provides fire and forget. It provides a request response. It provides a request stream, and it also provides some channel bidirectional communication. So we can take a look in detail. When we would like to use RSocket fire and forget, it means that we would like to just make a single request to the server and we don't expect any response. This could be cool just for some kind of notification when our server would like to expose API to receive notification, and we can just fire and forget to the server. Another widely known is request response, when we can just create a single request and we are waiting for a response. This is the same what HTTP provides. We have a request multi-response, which is when we are making a single request and we are waiting for a stream of responses. So it could be used for providing some kind of publish and subscribe, when we are subscribing to the publisher and we are waiting for receiving a stream of data. And there is some extra one, which is a request channel. So we have both 2 sides of our communication, and one of them is initializing the communication, and we can just push the messages in bidirectional way. It's similar to WebSocket. So all of these 4 of them are built in RSocket, and we have them provided by common in RSocket. We don't need to do anything, just using it. What is more, RSocket provides the mechanism for flow control. In order to explain how flow control can help us is this slide. So suppose that we have a client and a server, and when the client is making 1 message per second, 1 request per second to our server, it's cool. Later, when the client can make 500 messages a second, it can be a little overloading our server. When we are making 1000, our server can have some problems, for example, and finally, if we are making more and more, it becomes fire, and finally it can crash, because there is no mechanism for the server to inform us what is going on. You should stop, or you should slow down the communication. So RSocket provides a flow control mechanism, and there are two different flow control mechanisms. This async pull is originated from this reactive streams. It means that the client can say to the server, okay, right now I am ready to handle free requests. Please give me the response of free requests. So the client creates a demand to the server, and server will push the messages and will be waiting for the next two demands. So this is the cycle of responding and demands for the. It's really cool because the both sides can control the speed of the communication. So there is no chance to overload server on the client in this kind of scenario. And this is extra one idea for flow control. Another one is leasing. It would be really cool in server-to-server communication when there is server A and B, and server B issues some lease to the server A. So the lease can be something like this. Okay, within next 5 minutes, I can handle 1000 messages for you. And the server A can adopt his speed of communication to the server B and request with the rates which he received in the leasing. It would be very cool, for example, for Java application, when we know that there will be a garbage collector, when we know that the garbage collector is coming, so we know that we will stop for a while. So then we can issue lease just to don't do anything, we have a garbage collecting. Or it could be great if we have some application which is handling a job, a very long-running job, so it can load balance to different subscribers how many jobs you can schedule within a period of time. So this is a new flow control, and it's really cool using in different scenarios. And the most important part of RSocket is that the RSocket is only an abstraction layer. So we are using, the creators are reusing the existing WebSocket, TCP, and Aaron connection. So RSocket is built on the top of WebSocket or TCP or Aaron. When you are using RSocket, you just configure which kind of transport layer you would like to use. So it is cool to see the demo. How does it work? So WebSocket is right now ready in Node.js, Go, C++, and Java. I have a demo in Java. So let's take a look. We have just a simple main function. When we are starting the server, we are receiving the address of the server. Then we are starting the client. The client provides us the client socket. And here we are making some requests over the client we have. So let's see how we can easily start the server. We just have a Reactive Socket server, create. We are providing the transport layer which we would like to use. Here we are using the TCP transport layer. We are not providing the port, so the port of communication will be chosen randomly. And then what we need to provide to our server, we need to provide an implementation of socket acceptor. So this socket acceptor is the logic of our server, the business logic, how the server will handle the requests. So it's really easy, and finally when we start the server, we are returning from this function just the server address. Okay, let's come back to the start client. So when we have an address, we can start client using the received address. So it's it's using this asynchronous streams API from Reactive Java. What are we doing here? We are making a Reactive Socket client when we're providing this TCP transport using the address we receive from the server. We are configuring the keep alive connection, so we are disabling it, and we are disabling the support for the leasing because we do not implement it. We just make a connect, and this is a flow, so it means that when we are waiting here for the connection to be established, and when the connection will be established, we are just returning the Reactive Socket. Okay, so here we have a start server, here we have a start client, and right now we can make some request. So let's see how we can make a request. We are using the client, and on the client we can invoke fire and forget, request channel, request response, request streams. So this is this API which I have showed to you before. This is all these communication methods we can use it, and it only depends on the server side which of them are implemented, and we will see later how I have implemented them. So in our case, you are just making a request stream. So you'd like to request this. We would like to send the request to the server, and we would like to receive the stream of responses. So we are just sending a simple "Can you count me something?" And what do we have? We are receiving the publisher of the events. So we are receiving the stream of events. So we are mapping the events. So we are extracting the data from the response. You are just using a helper function to map the buffer of bytes to the string, and on every received response, we are just printing it out. And in our case, we'd like just to take 10 of them. So you'd like to just take 10 responses from the server. And finally, what we can do, we can close the connection, which I will go in detail later. And this is what we are making a request. So we are just saying to the server, "Can you count me something?" And we are waiting for 10 of responses. Let's see how the server has implemented this. So as I said before, we need to implement this socket acceptor. Oh, sorry, I lost. So we need to implement this abstract reactive socket. So this is this interface which we need to implement on the server on the side when we need to provide some support for fire and forget, request response, request stream, etc. By default, all of them are not implemented. So in Java, you need to implement them. So in our case, we would like our server to support the request stream. So what here we are doing? We are implementing this method. On every request from the client, we will print out the request. We'll see what will happen. And what we are doing, we can return right now the stream of event and the stream of responses. And in our case, the stream of responses will be interval stream. So every 3 seconds, we'll push some response, which will be just counting an incremental number. So it only depends on you, on your team, which of this communication pattern you will be used. Of course, as I said before, we can have a multiplexed streams within the same connection. So within a single connection, we can provide a support for this fire and forget, request response, request stream within a single connection, and all of this is abstracted by RSocket. So let's try it. Let's compile and we can run. So we have started this server on this port, and the server received this can you count me something, and the server responds with a stream of data. So it responds with a stream of this incremental number, next numbers every 3 seconds. And what we are, as I said before, we are waiting for 10 of them. So after the 10 of them, it should stop. Okay. Oh, cool. So we get the 10 of responses, and we have closed the channel. And this is another cool feature of RSocket. When we come back to the code, is that what we have done there, we can make a request to the server. It is asynchronous, so we are waiting asynchronously for the response. And suppose that this request was just scheduling some kind a long-running job, and this allows us to schedule the job and wait for the result of the job. But in the time when we are waiting for the result of the job, when the client decides, okay, right now don't need this job. Really, I don't need it. I don't need the result. So what I can do, I just can close the connection. I can close the stream. So the client has an ability to control the connection, the communication, and just say, okay, I don't need it. And thanks to that, the server can receive it, this information that the connection, the stream was closed. So for example, the server just can stop running the job. So it's very cool, because in these cases, we have built-in mechanisms for controlling on the client side, that we don't need the response. Great, so we can come back to the presentation. So what is RSocket status right now? It's still under development. It is available on GitHub. When you visit this RSocket IO, you can see all the implementation and the specification of protocol. It needs to be battle tested, and I was contacting with the developers from Netflix and Facebook, and they are using in some part of production and they are testing in the internal communication, and I hope that it will be in the future developed and maybe used as a communication layer, because it's a cool abstraction layer, and that's why you should try, in my opinion, because it's a single protocol with 4 interaction models, so you don't need to invent the wheel how to do it. You just have it built in the protocol. It has a built-in flow control mechanism, so it allows you to not overload your servers. And what is more, it's reusing the existing transport layers. So it is, for example, built on the top of TCP or WebSocket. So the transport layer is the same. The only you have a socket which is built on the top of that, and that's why it can be easily implemented by other languages and framework. So thank you very much. Yeah, we are using RSocket in our internal project so far in Code Heroes. We are testing it, and I hope that in the future we are going to provide the Scala API for this kind of protocol. So thank you very much. Do you have any questions?
And we